I'm Nathan Kennedy, and I'm going to be talking to you about our project, which was the Quest for Object X. Basically, we had to find a mystery object and figure out what it was. So our object was number 9, and our goal was to identify the object, and the different options that we had according to Vireo, which was the software we used, was a star, an asteroid, a normal galaxy, a QSO or a quasi-stellar object, a pulsar, or a planetary nebula. So we used the Virtual Education Observatory, or Vireo, which was made by Gettysburg College. And so we looked at different the object through the telescope, and just to see what it looked like, just looking at it. So this is what it looked like, object number 9. We also took a radio and spectrometer reading and compared the spectrometer readings to the other readings and other things we found on Vireo. And we took a radio reading and evaluated that and measured the redshift of the object, found the velocity and distance from that. So like I said, this was our object. It kind of looks like a galaxy, but as you can see in the middle, it's a little bit brighter. So we weren't sure, maybe it could be a star. We weren't sure just from this reading here. So this is the radio reading, and like stated before, other objects are non-detectable through radio readings. So we could read it, but it was very weak. It was very small through the 400 or 600 wavelength. So we decided that it was something that was with a weak radio signature, or was hard to detect. So here's a spectrometer reading. We compared it to the normal galaxy absorption lines, which are the red lines here. So as you can see, they don't match up very well other than this point, but 1 point out of 5 isn't good enough. So when we compared them, it wasn't really comparative. It wasn't a good comparison. So moving on, we compared it to a QSO, or inactive galactic nuclei lines. And these match up almost perfect. As you can see, this peak here matches here, here, pretty close here, decently close, and then it's almost exact over here. So the large peak at the beginning showed these are emission lines, and that matched with a QSO, and but a normal galaxy's absorption line. So it has a little bit of both, a normal galaxy and a QSO. So we looked at the redshift, and the redshift of object number 9 was 1.351 times 10 to the negative third, and the speed was 405 kilometers per second, which was too low for a QSO, and the distance was 29,116 megaparsecs. So it's pretty far away. So what it ended up being was an active galaxy. We weren't really sure what it was because it had different qualities from 2 different types of objects, normal galaxies and a QSO. So with a little help from Dr. C and further research online, I found from the National Museum of Natural History, according to that website, I was able to find that it was an active galaxy. And what an active galaxy is it's like a normal galaxy, except it has a black hole in the center, which is supermassive, and it emits up to 1,000 times more energy than a normal galaxy. So this black hole in the middle, it can emit light, but mostly there's light around it, and it can emit different gases out. So that's where the extra energy is coming from. So I just want to bring up, why does any of this matter? Astronomy, it's used in different ways. And originally in history, at the beginning of history, they used the stars for navigation. We still do now. If it wasn't for Einstein and relativity, GPS navigation systems wouldn't work correctly. And along with the military, different imaging and communication systems were brought about from research in astronomy. Along with technology, our cell phones wouldn't work with the radio waves and different satellites in the space. It wouldn't work correctly. And just sort of a recreational activity, it piques our curiosity. It allows us to find out what is out there in space, and to know that we're not just the only planet or only object or only stellar object out there. So those are my references.